But with this increased energy demand, we must also recognize the second part to the energy challenge: reducing environmental impacts and greenhouse gas emissions associated with energy use. Globally, we expect energy-related carbon dioxide emissions to rise by an average of 1% per year through the year 2030. Much of this emissions growth will come from rapidly developing nations. Meeting the challenge of reversing this trend in greenhouse gas emissions will require the help of every nation, industry, and consumer. Now, the history of our industry tells us that one of the most important ways of solving both parts of this dual energy challenge is to advance technology. We must bring innovators, companies, and even countries closer together through free trade and the free exchange of ideas to find and apply new technologies to old problems. What this means is we must pursue sound and stable policies that make it possible for the energy industry and other sectors of the economy to invest in the research and development of integrated solutions. Integrated solutions leverage technology to expand supplies, while at the same time increasing energy efficiency and reducing environmental impact. Integrated solutions can increase energy diversity by improving and advancing the efficient use of all economically viable energy sources. The efficient use of energy extends the life of the world's resource endowment. Over the past 25 years, worldwide gains in energy efficiency have helped lower global energy intensity by about 1% annually. Again, compounded, that's a big number. This efficiency overall translates into doing more with doing less. And recall that in my outlook remarks, we expect efficiency gains to be even greater in the future. In the Energy for Life program, you understand what research into new technologies requires from government, industry, and academia. It means we must have stable policies so that we can invest in promising research. It means we must educate new scientists, engineers, and thinkers. It means we must encourage human ingenuity to explore new and transformative ideas that will solve the challenges we face in the short, medium, and long term. In the decades ahead, the need for integrated solutions mean we will need to find more investment, more teamwork, and more international cooperation than ever before. The reality is that the world's conventional oil and gas resources are increasingly found in harsh environments, such as the Arctic, or in hard-to-reach places, such as the ultra-deep waters. Many projects in such environments will be beyond the capability of a single company, and many these days might even require international cooperation. The International Energy Agency estimates that the energy industry will need to invest more than $25 trillion in the world's energy supply infrastructure by the year 2030 to meet growing energy demand. Bringing new energy supplies to world markets will also require long-term planning, disciplined investment, and unparalleled project management and execution. Closer to home, the value of integrated solutions can be seen right here in Canada. Integrated solutions in the energy industry already create hundreds of thousands of jobs and strengthen Canada's economy. They are also increasing energy supplies and reducing environmental impact. What I'd like to do is discuss a few examples of how technologies are opening up new energy frontiers and how these advances will increase the already critical role Canada will play in meeting the world's energy needs. For decades, Canada has been integral to U.S. energy diversity and security. The fact, of course, is not going unnoticed at the highest levels of U.S. government. President Obama's National Security Advisor recently said, "The United States recognizes that our energy future is very much intertwined with that of Canada. Of course, many of you already know that Canada supplies the United States with 1/5 of its imported oil. As conventional sources become more difficult to reach, demand for unconventional sources will increase. About 13% of the world's known oil reserves are contained within oil sands, and Canada, of course, holds the world's largest reserves of this type. But as many of you in the audience know, producing and upgrading oil sands consumes more energy and water than conventional oil production would at the same location. That's why it's so important to develop integrated solutions that can improve both energy efficiency and, in this case, water use as well. We are seeing how improved technologies can help address this challenge already. Over the last 40 years, Imperial Oil has worked to pioneer state-of-art water recycling techniques at its Cold Lake operations. As a result of these improvements, since the mid-1980s, now more than 95% of the water used during the recovery operations is recycled to produce more steam. In addition, Cold Lake has become a model of how the energy industry can reach out to work with First Nations groups to refine the techniques that respect community priorities, create local jobs, and produce energy in a safe, secure, and environmentally responsible manner. Imperial's efforts at Cold Lake are just one example of how the energy industry can find mutually beneficial solutions when the dialogue is open and public policy stable. There are others. At the Kearl Oil Sands project, we are using an innovative and proprietary paraffinic froth process which generates pipeline-quality bitumen that will be blended with diluent for shipment. This technology requires less solvent at lower cost, making the tremendous oil resources at Kearl more economic to develop. It also means that the crude oil needs to be upgraded just once at the refinery, reducing energy requirements. Also at Kearl, we will be deploying cogeneration technology, which generates both electrical power and steam efficiently, reducing greenhouse gas emissions by an estimated 500,000 tons per year versus buying power off the grid. Kearl is also the site of some of our most creative ways to reduce our environmental footprint. Using a water storage system, we will reduce water withdrawal from the Athabasca River during the low flow periods in winter. Early in the process, we worked with government and the First Nations communities to identify ways not only to reduce and offset the impacts from the project, but to actually increase biodiversity in the area as the project progresses. On the gas side, for years the energy industry has known that North America holds vast quantities of tight gas and shale gas, natural gas locked in geological formations denser than concrete. Unfortunately, we lacked the technology to extract this gas in a cost-effective way. However, over the last decade, advances across a whole range of technologies have made the economic production of these resources possible. This has been a critical breakthrough, as our projections indicate that this increased gas production will be greatly needed. With its abundance and environmental advantages, natural gas is expected to be the fastest growing major energy source over the coming decades, increasing by more than 50% between now and 2030. And recall that I talked about overall energy demand increasing by just 35% between now and 2030. Natural gas up 50%. By then, natural gas is projected to have overtaken coal as the world's second largest source of energy.